Hello friends, so in today's class we are going to discuss about the electric current. So before discussing about the electric current, I will discuss about the water current. So what is the water current? Just consider there is a water tank. Okay, in that water tank, if water is stored, so just consider here water is stored, and through a pipe we can take the water to a down level. So if water will come through this pipe, and if I'll ask you what is the current of water through this pipe, so what we'll say, the rate of flow of water through this pipe is known to be as a water current. Correct? So here what we are seeing, there is a potential difference between the tank and the lower level. And because of this potential difference, we can say gravitational potential difference is there. And because of this potential difference, water starts to flow from higher level to the lower level. And this flow rate means what? Water flowing per unit time is known to be as a water current. Correct? And this potential difference is due to the height. In the similar way, when we are discussing about the electric current, here we are discussing about the water current. In the same way, if we are discussing about the electric current, so what is the electric current? Electric current is the rate of flow of electric charge. The rate of flow of electric charge, electric charge is called electric current, is called electric current. Correct? Okay. Now, any conductor, this electric current is there. Why I am not saying that this electric current is not in any insulator? Because there is nothing to carry that charge in insulator. If something is there to carry the charge, something is there that can make a charge to move, that is possible inside a conductor only. Why? So we know about the conductor insulator, the basic structure of the conductor insulator. We know that there are free electrons available inside a conductor only. In insulator, all electrons are tightly bounded by the nucleus. So there are nothing, means there are no carrier in an insulator. They can take the charge from one point to another point. So that's why it is not possible to move the charges from one point to another point. That's why there is a not possibility to flow of electric current inside an insulator. So this possibility is there only inside a conductor only. In insulator it is not possible. So what happens inside a conductor? There are free electrons. And free electrons means those valence electron, outermost orbit electron of atom of conductor. Those are not tightly bounded with the nucleus, and they can move in a lattice from one point to another point. As they can move, so that they can carry the charges from one point to another point. That's why the current can established inside a conductor. So we will discuss about this, that how they carry the means how they carry the charges. Is it possible in a conductor that without giving the potential difference by external source, is it possible that we can give the current inside a conductor? And if it's not possible, then what happens actually? So these are all the things we will discuss one by one. For now, we are just focusing on what? Definition of electric current. So definition of electric current is what? The rate of flow of electric charge is called electric current. It is same like as a rate of flow of water inside a pipe is called water current. Same way rate of flow of electric charge inside a conductor is called what? Electric current. So here we divide electric current in two types. One is the average current, and another one is a instantaneous current. Instantaneous current. So average current, we are saying that rate of flow of electric charge in total duration. Means for example, if delta Q charge is flowing from one point to another point in delta T time, then delta Q by delta T is what? I average. And instantaneous current, at a particular instant, how much charge is flowing in a conductor, that is what? Instantaneous current. So we can say instantaneous current is dq by dt. Correct? So this is the basic difference between what? Average current and instantaneous current. Now, here, if I will ask you that what is the SI unit of electric current? So SI unit is because it is what rate of flow of electric charge. That means charge flow divided by time. So we can say that its SI unit is coulomb divided by time. SI unit is what? Second. And charge SI unit already we studied in electrostatic. That is what? Coulomb. So we can say that it is what? 1 coulomb per second. And that is what? 1 ampere. So 1 coulomb per second is ampere. So SI unit of current is what? Ampere. It is denoted by A. It is what? Ampere. Correct. SI unit of what? Electric current is ampere, and dimension already we studied in unit dimension. It is represented by capital A or capital I. Correct. So here average current and instantaneous current, whatever question can come. For example, in average current, question can be asked like that: if there is a charge Q, it is given as 2t square plus t, correct, coulomb, and it is asking the current flowing from t equals to 0 second to t equals to 2 second, correct. So how to find the average current? So average current, I will put the final charge minus initial charge. So I will put this 2 here. So it is what? 2 into 2 square plus 2 minus, here initial charge is what? 0, correct? Divided by total duration of the time, 2 minus 0. So it is what? 2 into 2, 4, into 2, 8, 8 plus 2, 10. 10 divided by 2, it is what? 5 ampere. So average current is what? 5 ampere. At the same time, it is asking what is the current at t equals to 2 second. That means it is asking current at particular instant only. So that time I instantaneous we will find. So I instantaneous how? First we will differentiate q with respect to time. So here it is what? 4t plus 1. So at t equals to 2 second, if you put the value, it is 4 into 2 plus 1. It is what? 9 ampere. Correct. So here you see the difference. Here in instantaneous, we differentiated the Q with respect to time. We got the 4t plus 1. And then at t equals to 2, we put here and then we got here what? 9 ampere. But when it is asking 0 to 2 second, then delta Q we find it divided by total duration of time, that we got 5 ampere. So this is the difference between what? Finding the average current and instantaneous current. Okay, I hope you understood this. Next is current density. So what is the current density? So here current density, see here, already you studied about the area and area vector. When we need a scalar quantity and we do not need as a direction of area, so that time we only define area as a scalar. Okay, because there we do not need direction, only magnitude was sufficient for explaining the surface dimension. That time we define area as a scalar. But later on in electrostatic chapter, when we discussed about the electric flux, that time we need to define what? Area with direction. That time we define one new quantity. That is what? Area vector, whose direction is normal to the surface and magnitude is area of the surface. Correct? Same way, when we need current, only current means its direction we do not need. That time we define current as a scalar quantity. But when we need current as a current with a direction, its direction is also important. That time we define a new physical quantity that is known to be as a current density. So current density, it is defined as current per unit area. How it is defined as current per unit area. Correct. It means J equals to I by area, I by A, I by A. And its direction at any point is what? Direction of current at that point. So because here direction is a vector quantity, it's a what? Vector quantity. It's a vector quantity, vector quantity. So here we can say that its direction is direction of current at its direction at any point in a conductor its direction at any point in a conductor is direction of current at that point, is the direction of at a, in a conductor is the direction of current at that point, direction of current at that point. So how we define J equals to I by A? For example, here, if it is what? Surface cross-section area is there, this is conductor and the current is flowing like this. Okay, this is the current flow. And the area vector is always normal to the surface. So it is what? A vector, correct now? Understood? And this is the current direction. So how we define J? J equals to I by A. For example, if we will take the cross-section area of this is what, like this, little tilted, let theta angle tilted. If it will be tilted theta angle, is area vector also tilted by theta? A vector. Okay. And the current is in same direction like this. Okay, now theta is the angle between what? Current and what? Area vector. So that time we can write I equals to, because here this normal area of this current is what? A cos theta. A cos theta. We can say this normal component of the area vector is what? A cos theta. This is what? A cos theta, this part of this. So here we can write I equals to what? J A cos theta. Here when it is a what? I and A vector, both are in same direction. That time we write I equals to JA, where J is the current density. But when there is an angle between the current and the area vector, so that time we write I equals to JA cos theta. So here we can write I equals to J vector dot A vector, where J is what? Current density and A is what? Area. Correct? Okay. So this is for what? When there is what? Constant current density. This formula is valid. I equals to J vector dot A vector for constant current density. Constant current density. When current density is what? Constant. It's not changing. With any dimension, it's not changing. So for that, we will write I equals to J vector dot A vector, where J vector is current density, A vector is area vector. So 2 vector dot that is a scalar quantity. That's why it is I equals to J vector dot A vector. So constant current density. And because current density is current by area, so its SI unit is what? Ampere per meter square. So its SI unit is ampere per meter square. SI unit is what? Ampere per meter square. Okay. So I just use the word that if constant current density is there, we will use I equals to J vector dot A vector. So if there is no constant current density, it means current density is what? Changing. It's variable. So what we will do in that case? So we will see. So here, if J is variable, so in that case, if we have to find the current, so we will find the current first di. Already in the physics we have seen when the variable terms comes, we use the differentiation integration as a tool to find the total value. So di equals to, we will write j dA, correct? J vector dot dA vector. And then to find a total current, we will integrate this term with a proper limit. J vector dot dA vector. So with questions, you will try to understand how to solve this type of problem. For now, you just keep it in mind. If J is variable, we'll find the elemental current by using J vector dot dA vector, and then I will get total current by integrating dI. Now next uh, topic is current due to the variable current density. Already I have explained you here. Okay. So now we will solve the question based on this. Here in a long wire, a round cross section of radius r. Correct. A long wire. Just consider there is a long wire. Okay. And here the radius is what? R. And the current density it is given as J equals to, here current density it is given as J equals to Cx square ampere per meter square. Now find the total current flowing in the wire. It is asking what total current flowing in the wire. So as I just discussed with you that it is a variable because with the x it is changing, current density is changing here. So what we will do here? And it is what long wire, round wire, it is a long round wire. So you should find D area first. What is the elemental area? So see here, from the center as it is changing, varies with the radial distance. So from center it is changing. So from center I will take a elemental part. Let x distance, that is varying with x. And here if I am taking this, the thickness of this I am taking dx. This is what dx. So the length means parameter of this is what 2 pi x and thickness is dx. So d area what I will write 2 pi x into dx. Correct. So now if I have to write a di, I will write JDA. JDA. So J already given Cx square and the D value, dA value is what? 2 pi x dx. All constant we will keep together because C is also constant. So 2 pi C and then x square into x is what? X cube dx. Correct. Now to find the total current, as I discussed with you, that we will integrate this di. So we'll integrate this. So you know how to integrate 2 pi c and then x cube dx. See here, x cube dx integration. From where to where we have to integrate? 0 to r. We have to integrate from 0 to capital R because it's changing from 0 radially. From 0 to r it's changing. Now it will be what? 2 pi c and then x to power 4 by 4 here 0 to r. This 2 will cancel out here. So it is what? Pi c by 2 r by power 4 minus 0 by power 4. Finally, we will write here the current value will be 1 by 2 pi c r by power 4 ampere. Ampere. This is your answer. Ampere. This is your answer. I hope all of you understood this. Now, we will go for next concept. Drift velocity of a free electron. How to define the drift velocity? So just in the starting only, I discussed with you what happens inside a conductor. In a conductor, there are free electrons that we have already discussed. So those free electrons means what? They are free to move in a lattice. So here, just consider there is a conductor. If there is a conductor and this conductor in this free electrons are there. Correct now? So if we'll focus on one electron, so this electron is what? Free to move. Free to move. Correct? So if it is free to move, so is it establishing any current here? So I will say no, it is not establishing any current because at the same time, so many electrons are coming from one side to another side. So overall, if you will see any cross section, so number of electrons going from right to left and left to right are what? Same. As the number of electrons going from right to left are same, total charge from in any side, total charge from flown from any side to other side is what? Zero. Correct now. So that's why the net current is zero. Net current is zero. So what should we do to flow to for the flow of current? So हमें क्या करना चाहिए? So you see here what we will do in this case, we want current. So we want what? All the electrons should move in one direction only, and that is possible only when all electrons will experience the force in one direction, and that is possible when we will connect external potential source. Okay now. So here we will give a supply that generate the potential difference. And as it generates the potential difference externally, and that is done by the battery or any supply source. So it is creating what? Potential difference, higher potential difference one side and lower potential difference another side. Correct? So due to that, electric field established from higher potential to lower potential. Okay now, higher potential, this is higher potential line becomes, and this is what? Other side, lower potential line. And to that, in a whole conductor, what happens? Higher potential and lower potential and generates, and the electric field established from higher potential to lower potential line. Now what happens? All the electrons will start to experience the force in one direction because electron having negative charge, and you know already that on negative charge the force experience in opposite direction of electric field. So here all the electrons will experience the force in this direction. Correct. Now question arises Now they will start to flow with a very high speed. Why? Because normally what we experience, we turn on the switch, bulb glow. We turn on the switch, immediately fan works. So it means electron speed is very fast. No, still electron speed is not fast. Drift velocity. This electron moves with a velocity that is known to be as a drift velocity. So drift velocity here is what? Drift velocity. Velocity with which electron moves. Velocity with which electron moves in a conductor. Electron moves in a conductor. Moves in a conductor. Correct? Understood? So drift velocity, velocity which with electron moves in a conductor. Its order is what? What is the order of this? Drift velocity's order is 10 to power minus 4 meter per second, or nearly 10 to power minus 4 meter per second. So you can imagine it is 0.0001 meter per second. It's very slow. Then how it is possible that we turn on the switch and the bulb works immediately? We turn on the switch, fan works immediately. This is because when we turn on the switch, that time immediately electric field established in whole circuit with the speed of the light. So everywhere electrons start to move at the same time. That's why bulb will glow in fractions of the second. That's why fan will work in fractions of the second. It's not that this electron will go, then the bulb will go. Are you understanding? One electron movement doesn't matter. Every electron start to move at the same time because electric field established with the speed of the light. So now this electron, just we will focus now. This electron, every electron moves with what? Drift velocity, and that is the order of what? 10 to power minus 4 meter per second. Now I will focus only on drift velocity because our topic is what? Drift velocity of free electron. So just consider one electron is there and its speed is what? Vd meter per second. That means in 1 second, it moves how much meter? Vd meter. And here we take small n as what? Number of electrons per unit volume. Number of electrons per unit volume. Per unit volume. Correct? Okay, now number of electrons per unit volume. Okay. Now n is number of electrons per unit volume, and in 1 second it moves Vd meter. And just this cross section I consider A. A is what? Area of cross section. Area of cross section of conductor. Area of cross section of conductor. Now just consider if it is moving with Vd meter per second, in 1 second it is moving Vd meter. So just see here. Here it covers Vd meter here. Okay. So in 1 second moves Vd meter. So T we consider what? 1 second. T what we consider? It is as 1 second. And area is what? A. So total volume is what? Of this section? A into Vd. A into Vd. So volume of this section is A into Vd. Volume of the section, or you can say volume of free electron covered in 1 second is what? A into Vd. So can I write like this? Here, if I have to write a current, I, if I have to write, I is what? Normally total number of electrons into total charge, or charge on total number of electrons into charge on each electron divided by time. I equals to Ne by T. I equals to what? Ne by T. So here, total number of electrons, what can I write? Total number of electrons, what can I write? We know number of electrons per unit volume is small n. Okay. And this is number of electrons per unit volume. So how much volume in 1 second? So in 1 second, it is what? A into Vd. So volume is A into Vd. A into Vd. So this is what? This is what? N by T value, where T is what? 1 second. Number of electrons in unit time. Number of electrons in unit time. This is NAVD by 1 second. So here we'll know N by T value. N by T value we know into E. So we'll put this value here. N is what? NAVD. N by T is what? NAVD into E. Now here we are getting the I value. Current value is what? NEAVD. And from here we can write Vd equals to what? Vd equals to I by NEA. Correct? We can write I by NEA. Correct. Here you can also see that I by A is J. So we can write J by NE. J by NE. We can also write J equals to NEVD. So this all the important formulae. According to requirement, we will use it. J equals to NEVD, VD equals to J by NE, I equals to NEVD. Okay, now according to requirement, we will use all this formulae. I hope all of you understood. We'll go for next concept. So now relation between drift velocity and current density. So here same we have defined relation between what? Drift velocity and current density. What is that? J equals to NEVD. Okay, now where J is what? Current density, VD is drift velocity, N is number of electrons per unit volume. N is what? Not number of electrons, number of electrons per unit volume. Correct? E is what? Charge on each electron. Okay. E value is what? Charge on each electron. 1.6 into magnitude wise, it is what? 1.6 into 10 to the power minus 19 coulomb. Okay. Now here, what is given? Current of 16 ampere. Current of 16 ampere. So I value what given? 16 ampere. Okay. Now pass through a conductor which concentration is what? 4 into 10 to the power 28 per meter cube. It means this is a small n value given because number of electrons per unit volume is what? Small n. So 4 into 10 to the power 28 per meter cube, number of electrons per unit volume given. And its cross section area also given. That is how much? 10 to the power minus 5 meter square. Find the drift velocity of the electron. So just we studied what is the drift velocity? Drift velocity equals to what? Just we studied here. What is the drift velocity? Drift velocity equals to J by NE, J by NE or I by NEA, I by NEA. So I by NEA. We'll use this formula here. So I is what? 16 divided by number of electrons per unit volume. It is what? 4 into 10 to the power 28. E is what? 1.6 into 10 to the power minus 19 coulomb. And A is what? 10 to the power minus 5. Correct. Now we'll solve this. So it is what? 1.6. This is 10 times. Okay, now. So here 1 by 4 is there. 1 by 4 we can write 0.25. Correct. Now here 10 to the power 28 will go up. 10 to the power minus 5 will go up. Here we can write 10 into. Here 10 to the power minus 19. So 10 to the power plus 19 minus will become plus 5 and plus will become minus 28 here. Okay. Now here it is what? 2.5 into. Now you'll see 2.5 into. This is what? 19 plus 5. It is what? 24. Then 10 to the power minus 4. This is what? Meter per second. As I told you, the drift velocity in the order of 10 to the power minus 4. So here you can see the electron velocity is in the order of 10 to the power minus 4 meter per second. 2.5 into 10 to the power minus 4 meter per second. This is the answer of this question. Now, Ohm's law. We will come to the Ohm's law. So Ohm's law already we studied in the class 10th. So what we studied in the class 10th, that according to Ohm's law, V is proportional to I, that we know, V equals to IR at constant temperature. Correct? So this already we know. We will study here Ohm's law with little different way because we know now the current density, we know now conductivity. Oh, one more thing, I have not discussed about the conductivity. Okay, so that I will discuss. Even I have not discussed about the resistivity also. So that one I will discuss with you. Correct? So here, few things first I will discuss with you. Here, what is the conductivity? What is the resistivity? These all the things we will discuss. So as I discussed with you here, VD, drift velocity. Here we have discussed what? Drift velocity. So drift velocity, what I have discussed? Here VD equals to what we have discussed. Here you see VD equals to J by VD equals to what? J by NE. Correct? Na? VD equals to J by NE. We discussed. Now, after this, relation of drift velocity and current density was there. So J equals to NEVD and VD equals to drift velocity only. If I will discuss about the drift velocity, we can say that, for example, here, if there is a conductor, and if we connect with the external supply, so electrons will start to move. Electrons will start to move. Correct? Okay. So now when electrons will start to move, It is colliding with its neighbor electrons. It is colliding with what? It's a neighbor electron. As it is colliding with its neighbor electron, it is getting opposition force. It is getting what? Opposition force. So the opposition force, we can say that this opposition force, we can say this opposition force A equals to what we can say here, the electric field is there due to this supply. So higher potential and lower potential is there. So we can say this electric field is there. So acceleration, we can write the external force, that is what? E into E minus F opposition divided by total mass, correct? And here we can say that acceleration is here is almost, because it is constant speed drift velocity we are considering, so that's why we consider acceleration almost at 0. Okay, so here we can say that EE equals to F opposition, correct? F opposition. Okay, and opposition force on the electron that is moving, it depends on how much speed it is. If its speed is more, its opposition force is more. So we can write that F opposition is proportional to the drift speed, correct? And F opposition, we can write it as a KVD, where K is constant. So here also we can write it as a KVD, correct? And then VD equals to, you can write E by K into E. And this E by K term we are defining as mu. And where mu is what? Mobility. So finally we got VD equals to what? VD equals to mu into E. VD equals to mu into E, where VD is what? Drift velocity. Where VD is what? VD is here drift velocity. Drift velocity. Velocity. And mu is mobility. Mu is mobility. E is electric field. E is what? Electric field. Electric field. Okay, na? So this is what the terms, and this is the relation between what? Drift velocity and what? Electric field. VD equals what? Mu into E. So we have some relations. One by one we will discuss that. So we got the relation I equals to NEA VD. We got VD equals to what? Mu into E. Correct? These two relations we got. Now we can write I equals to NEA VD value, we can write mu into E. Correct? So here we can write NE mu. NEA mu, we can write here. It is what? NEA mu E. Because VD equals what? Here you see this one formula. I equals to NEA VD we have written, and VD equals to what? We have written mu into E. So here finally with these two relations we can write I equals to what? NEA mu into E. Correct? So I think so all of you understood here. Now what can we relate here? NE mu. Mu is what? Mobility. And mu is what? Mobility. So now the relation between mobility and conductivity, what can I write? So mobility we can write mu. So conductivity, here new term we will define conductivity, that is nothing but the NEA mu. NEA mu is your what? Sorry, Ne mu is your conductivity. Ne mu is what? Conductivity. So here I will write here new term I will define conductivity. Conductivity, and conductivity is Ne mu. Now, how if I have to write any mu, and this A I will take other side. This is what? I divided by A. So this is what? Ne mu into E. Ne mu into E. So finally, I by A we can write current density J. J equals to sigma into E. Correct? So J is your current density. J is your current density. Current density. Okay. And sigma is your what? Conductivity. Already I have defined. Sigma is your conductivity. Conductivity. And E is your what? Electric field strength. Electric field strength in the region of the conductor. Electric field strength. So it can be also written J vector equals to sigma E vector. Correct? So J equals to sigma E we got. Now you should know that resistivity is what? Sigma equals to 1 by rho. Means resistivity is reciprocal of conductivity. More conductivity in a conductor means its resistivity will be less. Less resistivity means more conductivity. Same way, high resistivity means less conductivity. So resistivity we can write 1 by rho. So this can be also written as 1 by rho, 1 by rho into E. J equals to 1 by rho into E. Now with this relation, we will prove the Ohm's law also. For example, there is a wire, there is a conductor, okay, and we will connect a supply through this, correct? So here higher potential end and here lower potential end, electric field from higher to lower, E vector. Now here the length of the conductor is L, so we can write the potential difference across this V. So E equals to, we can write V by L. E equals to V by L. Okay now, and this relation already we know. J equals to 1 by rho E. J equals to 1 by rho into E. Correct? And J equals to, we know, I by A. J equals to I by A. And this is what? 1 by rho. E is what we can write? V by L. V by L. So here we can write, V equals to, just cross multiply, V equals to rho L by A, rho L by A into what? I, into I. So here we can write V equals to what? I into R. V equals to I into R. So we can say V is directly proportional to I. This is nothing but the Ohm's law. This is nothing but what? Ohm's law. Ohm's law. Correct. And here R is resistance of the conductor. That is what? Rho into L by A. Where rho is the resistivity, L is the length of the conductor, A is the cross-section area. Resistance of the wire. Resistance of a wire. Resistance of a conductor. And its SI unit is what? SI unit of resistance is what? Ohm. It's a ohm. Correct? So I hope all of you understood what is the Ohm's law. And this law is valid at what? At constant temperature. At constant temperature. Okay. So this is what? Ohm's law. Now, what is the circuit symbol of the resistance? So resistor, it's having its own polarity. So what we take, where it enter, where the current will enter in the resistor, that end we will take the plus sign. Where it leaves, that will take what? Minus sign. For example, if I will take cell, so cell having its polarity, lower end is what? Minus, longer line is what? Plus. But resistors haven't its own polarity. So anywhere in the circuit, whenever we have to show its polarity, so what we will do? Where the current enters in the resistor, that end will be considered as a plus. Where it leaves, that is what? Minus. Here, if potential is VA, here potential is VB. So plus why we are saying? Because VA is greater than VB. At this point, the potential is greater than this point. Correct? Now, next is, what is the effect of the temperature on resistivity? So for example, if I will take any conductor, correct? So in that, what happens? Electrons are moving with zigzag path. Let it is at T1 temperature. Now, if I will lower the temperature, in the same conductor, what will happen? If I will lower the temperature, means T2 is less than the T1. So this drift will what? Decreases. Drift will what? Decreases. Correct. Even if I will lower more temperature, let T3 temperature, T3 is less than the T2 also. So further the drift will decrease. Further the drift will what? Decrease. Correct. Okay. And at 0 Kelvin temperature, at 0 Kelvin temperature, what we found? Almost the electron moving in the straight path. Almost in the straight path, the electron is moving. And that state of the conductor is known as superconductor state. Superconductor state. Okay, now that's why we are saying superconductor state is normally what we are taking. means at 0 Kelvin temperature, because there the electrons have a what? Very high drift velocity and very less collision is there. Okay now, so that is what in the case of what superconductor, very low temperature at 0 Kelvin temperature we consider. So based on this, the relation of resistivity, we got rho t equals to rho t naught into 1 plus alpha delta t, correct? Where rho t is resistivity at T degrees Celsius, rho t naught is at 0 degrees Celsius or reference temperature. Alpha is what? Coefficient of temperature. Alpha is what? Coefficient of temperature. Coefficient of temperature, correct? And its unit is per degree Celsius or per Kelvin. Delta T is what? Change in temperature. Again, I am telling you that rho T is resistance resistivity at T degrees Celsius. Rho T naught is resistivity as reference or 0 degrees Celsius, and alpha is coefficient of temperature. Its unit is what? Per degree Celsius or per Kelvin. If we will consider, it means dimension, thermal dimension, if you will consider it's not changing with the rise in temperature, then resistance we can write same way, RT equals to RT naught into 1 plus alpha delta T, where RT is what? Resistance at T degree Celsius, RT naught is what? Resistance at 0 degree Celsius or at reference temperature, and alpha is what? Coefficient of temperature. Delta is change in temperature. This is what the relation between resistance, resistivity and temperature. Now here one question is that copper coil has a resistance. Here it is given a copper coil has a resistance 20 ohm. Correct? It's having what resistance? 20 ohm at 0 degrees Celsius. Okay now. And resistance R dash is 26.4 ohm at temperature what? T dash is what? It is T initial, and you can say it as a T final. It is as what? T, we can say it as a T initial is at 0 degrees Celsius, and T final is what? 26 point, sorry, it is T final is 80 degrees Celsius, 80 degrees Celsius. Find out the temperature coefficient, alpha it is asking. So we already know R dash equals to R final is equals to R naught. At 0 degrees, what is the temperature? 20 ohm. 20 ohm into 1 plus alpha. Delta T is what? 80 minus 0. Correct. So here we can write R dash value is how much? 26.4. So we can write it as a alpha into 80 equals to 26.4 alpha into 80 and 26.4 minus 20 divided by it as a it is 20, then it is alpha equals to 26.4 minus 20, it is 6.4 divided by 20 into 80 per degree Celsius. If you will divide, we will get the answer. Correct. So if I will do it, what I will get, we'll solve this. It is 6.4 and 8 into 2 is 16, and it is 10 to the power minus 2 is 0.4. Then it is what? 4 into 10 to the power minus 3 per degree Celsius. This is the answer. I hope this is the answer only. Our calculation, if our calculation is correct. Okay, so I think so all of you understood this topic. Now next one is grouping of resistance. In grouping of resistance, we have two types of grouping. One is what? Series combination. One is series combination, and another one is what? Parallel combination. Parallel combination. So one by one, we will discuss about this. So what happens in the series combination? So in series combination, what happens? When the resistors are connected one after another, for example, this is resistor 1, this is resistor 2, and this is resistor 3. This is R1, R2, and R3. When they are connected one after another, like this. Okay, na? So what happens? The current going in first resistor, if we connect this across any cell, then only current will go. So here current going in the first register, the same current coming out from the first register, the same current is going in second register, and the same current coming out from the second register going into the third register. Then we say all three are in series. See here important wording I am using. Series means what? When the current are same, which current? The current coming out from the first, the same current is in the second, and current coming out from the second, the same current in the third. Then we say it is what? Series combination. Correct? Here supplies of CE is there. So we can say that here or we can say it is V, for example. Here potential difference generated across this is what? V, total potential difference here. So here according to Ohm's law, we can say here the drop is V1, here the drop is V2, and here the drop happens, that is what? V3. So total drop V equals to what can we write? V1 plus V2 plus V3. So in place of this 3, if we want one register, we are saying what? Series combination. That is nothing but the R equivalent. Okay. And the supply is what? V. And the current is what? I. Okay. So here we can write, here V equals to, according to Ohm's law, we can write I into R equivalent. So here we can write V equals to I into R equivalent. V1 equals to what? I into R1 plus I into R2 plus I into R3. Now I cancel out. So finally we got what? R equivalent equals to R1 plus R2 plus R3. Correct? Okay. This is what series combination. Similar way, if I will discuss about the parallel combination. Parallel combination. So what happens in the parallel combination? So in parallel combination, when registers are connected such a way their ends are common. What I am saying, their ends are common. Means this is the one end, this is the another end. When ends are common, we say that they are in what? Parallel combination. For example, R1, R2 and R3 are connected in parallel combination. And cell is here. Supply is what? E. Okay now, or you can say it is V, for example, if it is a V. So let current is going I, it is divided in what? I1, I2 and I3. What is here you are finding? That common potential difference across each register because their ends are common. So always when we have to check parallel combination, we have to check their ends are common or not. If their ends are common, they are parallel combination. Okay. So now we can say that here current divided in 3 sections. So we can say I equals to I1 plus I2 plus I3. In place of this 3, I want one register. That's why it is parallel combination. So here one register is there that is equivalent to this 3. Okay. And here that current we can write I equals to total supply from V divided by R equivalent. Correct? So here we can I equals to V divided by R equivalent. Same way I1 we can write V divided by R1. Same way I2 we can write V divided by R2. Same way I3. This is I3. So I3 we can write V divided by R3. V common, it is cancel out. So finally we get what? 1 by R equivalent equals to 1 by R1 plus 1 by R2 plus 1 by R3. Correct? So this is what parallel combination. Now if n equal registers, one note you can write here. If note you can write. If n equal registers, registers, registers are connected in series, are connected in series, connected in series, then R equivalent will be R plus R plus R plus R. That is what? N into R. Correct? In the same way, if N equal registers are connected in parallel, are connected in parallel. So what can I say? In parallel, R equivalent will be what? So we can say 1 by R equivalent is what? 1 by R plus 1 by R plus 1 by R. So n times. So we can write 1 by R equivalent equals to n by R. So R equivalent to R by n. So here R equivalent equals to R by n. Correct? So I hope so. This lecture, all of you understood. If there is any doubt, you can ask me in comment section. And we will continue this class, next lecture in the next video. Thank you.